Hi everybody, Cam Sweet here from the Garage Connection, coming to you today with a video hoping to fix this machine behind me. So what we're going to do, we're going to talk about very briefly the machine and what the problems seem to be, and then see what we can get into. I've been meaning to fix this for a while. Life gets in the way, it is what it is, so let's get after it. Okay, so this machine behind me, it is one of those mini Bobcats that are popping up at the auction. However, this is not the gasoline version, so this is a diesel version of the KRW232 or whatever it's called. This one's labeled as a JK35. I don't know what JK or 35 means, but yeah. So it's got an 1105 Kubota in it. It is broadly similar to that high top unit that I got at the auction, and this one was purchased from Ritchie Brothers back in February. It's been sitting since then because, unfortunately, although it drives very well with the joysticks, the pump that lifts the arm and does the bucket and all that stuff, something is wrong with the pump or a setting somewhere, and so the unit is not performing pretty much any function well. So what we're going to do is we're going to take a look at what we got going on and see if we can come up with a solution, because I want to put this thing to work and I can't do that with a pump that's messed up. Another side note, some people have mentioned the wheels. So yes, I got rid of the pizza cutter wheels that came on this thing and I went to a wide balloon type tire. I promise I'm going to do a video about that. I bought these when they were on sale and now they're like sold out everywhere because somebody figured it out. So I promise I'm going to get to that, just not right now. All right, so on this unit, we got the engine here and it's bolted to two hydraulic pumps, all right? One of these pumps does one side, the other one does the other side drive wheels. And then on the front of it, right about here, it's under this plate, there is a gear type hydraulic pump that runs all of the aux functions of the machine. So as it functions, this one does the left tires, that one does the right tires, front, back. And then if you go in and out, you do a function of the arm movement or the bucket movement. Now, all of that movement is controlled down here. So we have a directional control valve. And as you can see, there's three different sets of spools down there. So this thing I'm pointing at right here, that's the aux hydraulic connection. And that actually operates off a foot pedal down there. So obviously, because we have hoses coming off this aux connection and they go down to this most, in our view here, left-hand spool, that's going to be for the aux connections. And then these two spools are going to do either the big arm going up, or they're going to do the bucket tilt. All right, so there's a couple things that I want to check on this unit. So because of the way that this thing is made, there is really three things that we could have an issue with, all right? The first thing could be the pilot pressure, which is actually telling the spools to open and close. If the pilot pressure is too low, the functions won't work properly and they will be either sporadic or weak. So that's thing one, all right? Thing two is the pressure relief valve that controls the pressure coming out of that pump could be set too low, in which case the arms will be very weak, the bucket will be very weak, but it shouldn't really affect the pilot pressure. And the third option, which I'm hoping, fingers crossed, is not likely, is that the pump is actually bad and they're all kind of a function of one another. So what we're going to do, we're going to take like an Amazon pressure test kit. I'm going to tap into the pilot line coming into one of the functions, and I'm going to tap into the pressure port on the cylinders and see if there's a great disparity in some of the pressures that are coming out. Before I do that, what I'm going to do is lower the cab. I'm going to fire the machine up and I'm going to show you what the issue actually is. I actually forget how to lower the cab. Nope, never mind, there it is. You gotta kind of sneak these little arms up out the way. There we go. Also, before we get too far into this, I want to point out that yes, I am wearing flip-flops, and hopefully that means I still know what I'm talking about with hydraulics, because some people have commented that you're wearing flip-flops, you must not know anything. So let's do it. All right, I'm gonna fire it up here. Hopefully I don't ruin the audio. All right, so right now, this is what happens if I go to do anything. So if I go to curl the bucket, it's very choppy. Now, once it gets all the way up though, it loads the machine up. So that's a good sign in terms of that hydraulic pump. Very, very weak. And if I make any other movement when I'm doing that, it instantly just completely kills off any of the momentum. So this is what we got going on right now. It's a very lethargic, slow movement. The only positive note is if I complete the movement, it loads up. And that's a good sign that it loads up, because that means that the pump itself is putting out some sort of pressure. If you haven't purchased one of these kits by now, these little Amazon pressure test kits, you really ought to get one. The thing I like about it is, in addition to a bunch of different ranges of gauges, you actually have the ability to like tee off some of these lines. So you have the ability to go in line with some of the hydraulic lines and then connect your pressure gauge right to that. And that's so valuable for troubleshooting these machines. What I'm really hoping is not the case is that there's a restriction on the suction side of the pump, and that's causing the sporadic kind of jumpiness of the controls. The reason I hope that's not the case is that would mean that there's something wrong down inside the hydraulic tank, and just by the nature of where the tanks are in these things, it'd pretty much be a nightmare to go out and fish that out. So fingers crossed it's not that, or the pump isn't bad. I'm hoping it's just a pilot pressure issue. So let's see what we come up with. I'm gonna go get these lines hooked up. Okay, so we've got our gauges hooked up here. What I chose to do was to tap into the bucket curl. I figured that was the easiest thing rather than trying to move these big arms up and down. So I've got two different gauges here. This lower pressure one, or excuse me, this higher pressure one is going to be for the actual force that the bucket cylinders are seeing. So I want that to be around 2,500. Shut up! I want that to be around 2,500 if I can help it. Then this one's going to measure the pilot pressure. So this is actually the force that the joysticks are exerting on the directional control valve to move the spool and create the movement. The one thing I don't know, which I'm hoping, is this one is hooked up to the curl, not the dump. I don't know if this one, depending on what side of the DCV it is, I don't know if this one's also hooked up to the curl. It could be the dump. It's not a big deal. All I'll have to do is just push the bucket all the way into the ground, basically, and everything will be fine. So we're going to try to do this with the cab up. The machine should start, and I should be able to override the little arms there and give us a successful test. So let's see what we come up with. All right, perfect. It's the right way around. So pilot pressure. Yeah, 250, I mean, that's about right. Okay, so let me see if I can get a close-up to show you what's going on. Let's dump that force down. Okay, pilot pressure, pump pressure. So I go to curl the bucket. You see that pilot pressure jump up? That's how much force the control valves are seeing. All right, so what does this tell us? Well, there's a few different things going on here, and I want to try to make sure I articulate this the correct way. So there's flow and there's pressure, okay? Flow is what the pump is producing. Pressure is the resistance to the pump producing flow. So we can have a very high pressure with a very low flow. We can also have a very low pressure with a very high flow. So think pressure washer versus garden hose, okay? But the truth can kind of lie somewhere in the middle. So what does that mean, Cam? All right, to move this bucket upwards very slowly, it takes almost no pressure and it takes almost no flow. All we're doing is just lifting up a bucket. So does that give us an indication of what's going on? Not really. But when we come up against resistance, or the bucket being all the way up, the cylinders being maxed out, when I see that pressure jump all the way up to like 24, 2500, what does that tell me? That tells me that when I'm doing a movement with the hydraulics that does not require a tremendous amount of flow, but I'm resisting whatever flow the pump can put out via the pressure relief valve, that means that the pump is capable of making 2500 PSI in an application where it doesn't need a lot of flow. So what we have here is not a pressure problem, and I personally don't think it's a pump problem, because if that pump was grenaded inside, I don't think that we would be able to make 2500 PSI. So what we have here is a flow problem. And judging by the jumpiness of the flow, what that feels to me, it feels like cavitation, all right? There's two different types of issues downstream, or let me take that back. There's two different types of issues prior to the pump, generally, that plague hydraulic systems. The first one is aeration and the second one is cavitation, okay? Aeration is a loose fitting or a rub-through hose, and it's causing the pump, by its nature of pulling fluid out of the reservoir, it causes air to slip in to that, and it creates a very high frequency, like sucking sound, like when you get to the end of your drink and your straw is kind of like, it's like picking up air. That's kind of what it sounds like, but it's a high frequency, and the pump doesn't really do anything different. It's just a very high frequency kind of sound. And that's bad, but that can usually be fixed very easily by fixing your messed up hose or tightening up your fittings or whatever. And then there's cavitation. Cavitation is something different. Cavitation is where there's a resistance to flow prior to the pump, and there's no way for air to get in. So essentially the pump is pulling, but it's pulling more than the fluid that's coming into it can provide. And so you actually start to, basically you separate the fluid from itself, and you pull out gases that are trapped inside of there. So you're essentially literally ripping the fluid apart, and gases are filling that void. And cavitation, usually it's kind of got like a, I'm going to do my worst impression of cavitation, but it's like a ying 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 ying. Like it's got a very like crackly kind of, it's a really weird sound, but once you hear it, you'll be like, that's cavitation. And what the hydraulics are doing with their kind of jumpiness like that, unfortunately for me, it seems like it's cavitation. So now what I have to look into is problems prior to my gear drive pump. So I'm going to be taking the pump suction line, working that all the way back, and figuring out is there a restriction, is it kinked, or unfortunately, is there a problem in the hydraulic reservoir? My drive motors do not have that problem, so I'm hoping that it might be just like a suction strainer is clogged up somehow, or maybe somebody forgot to take the packaging off. That'd be really convenient if it was like that. So yeah,